Morning. Samuel.
Yeah, morning.
How are you?
Yes. I'm good.
Today our
Sio umetuweka.
Nimeweka sana. Nataka mpitie note.
Hata ni watafute.
Nitaka mpitie.
Yeah.
Nasema?
Kuna kitu ulikuwa unasema nataka tu.
Nilikuwa nataka mpitie notes kwanza.
Ulituma?
Kwa portal kwa system ipo.
Sasa sikuingia portal sijajua.
Haujaingia. Kitu na discuss sasa je kwa portal. Lesson 3 na 4. Content iko hapo, audio, video iko hapo, theory notes, yani text ziko hapo, then kuna past papers yenye faa mtumia mkipitia through for revision. So is everyone okay?
Bado watu hawajaingia bado. Yeah, like 3 people here I can see.
So I believe majority of the people have joined, so we can start our meeting, I guess. So when you look at the portal, I want to share my screen. When you look at the portal, we have a discussion, a forum. I came up with a forum last week, but nobody joined that forum. And on that forum, there's a discussion in terms of defining what is booting and distinguishing between warm booting and cold booting. Those are 2 forms of booting. Only 1 person joined that discussion. This is a form of an assignment also, but the mode of this assignment is basically discussion, general discussion, where I post a question, then you start responding on that question. But only 1 person will join your discussion. So to join that discussion, you can see on my screen, kuna mahali imesema open discussion. You just click on it. Once you click on that open discussion line, then you can enter a discussion, whereby we have question number 1, define the term booting. It is out of 2 marks. So what you can do, you click on add a new topic. Add a new topic. You click on that button. The question you are answering, you type on the subject. For example, I'm answering question 1, defining the term booting. I can just type question 1, or I say definition. Definition of the term booting. Then I come and answer here. I put my answer. I say Booting is a process. Booting is a process. Process of starting up a computer. Starting up a computer. Starting up a computer is same as turning on a computer. Booting is a process of starting up a computer or turning on a computer. Once I type my answer, then I click on post to forum, so that anybody can view that answer of mine. Post to forum. That's how you can enter a forum. So here, when I look at my dashboard, only one person, that is the class rep of EcoBank, Hulda Ocheng, only one person joined that discussion. So what I did, I just put an answer on question 1. Booting is a process of starting up a computer, and there are 2 forms of booting. One is known as warm booting, another is called booting. Another name for warm booting, you can also call it soft booting. Then cold booting is known as hard booting. So that process of restarting a computer, which is already turned on, is known as warm booting. And for you to restart a computer, it means your computer has challenges. It's not responding. You are performing a given task and the computer is not responding. So you do what you call, you restart that computer. For you to restart a computer, you can combine keyboard keys, shortcut keys. You combine Control, CTRL, plus alternate key and the delete key, which will now come up with an option, a dialog box, which can allow you to restart your computer. Now, cold booting is a process of starting a computer that is not turned on. How? The computer has the system unit and the monitor. The monitor uses power. The system unit also uses power. So what you can do, you just press the power button of your monitor and the power button of your system unit, the CPU. That's what you call cold booting. Any question on that?
I have a question.
Yes.
Say unasema cold booting.
Yes.
Unasema una press monitor na CPU.
The monitor iko na power button. CPU
Yes.
iko na power button. Meaning monitor imetumia power. Lazima iko connected to the power supply kutoka kwa main ya Kenya Power. The CPU pia lazima iko connected to the power source of the mains ya Kenya Power. You have a cable ya connect. So you have to power that CPU, you have to power the monitor. So that process, you're pressing the power button ya monitor and pressing the power button ya CPU is what we call cold booting.
So hii ni kama kuflash.
Yes?
Ni kama kuflash nini?
Hapana.
Computer.
Hapana. Imagine you have
Okay.
uko na TV. Na the TV izima. Si iko na power. Button, iko na power button, ndio. Then iko na cable ya connect the TV na power source. Sinakuwa na cable. So you make sure that the cable ya power from the TV kwenda kwa, let's say, kwa extension iko connected. Then you unafinya the power button ya TV yako. So that process inaitwa nini? Called booting. So the same happens to a computer. I'm working with a computer saizi. After some time, I shut it down. Naizima. Once naizima, after some time, I want to operate that computer. Nataka kuitumia. What I can do, I just start up my computer. How? By pressing the power button ya monitor, power button ya CPU. But you have to ensure that now those two are powered. Kwanza ndio finye. So that process of pressing the power button ya CPU na power button ya monitor is what we call cold booting. You are starting up a computer. The same to a mobile phone. Mobile phone, kama uko na simu, then iko off. Umeitumia, let's say, charge ikaisha kaenda off. then umeicharge, si lazima uiwashe. Na siko na power button, ndio unaona unafanya power button. That process inaitwa cold booting. Now when let's say my mobile phone is on, I want to type a message kwa WhatsApp and that mobile phone is not responding, imehang. So what I do, I restart my mobile phone, I press the power button continuous, alafu nileta option ya restart or ya kuzima. That process is a warm booting. You can also do the same kwa computer. Iko sawa? Now we want to proceed, unless mtu ako na swali. Want to proceed. As at now, what I'm covering is still on hardware. I'm still covering hardware. And when you look at, because I'm the one teaching, I was the one teaching that book here, Greenspan na EcoBank. So Greenspan, before we went for a break, nilikuwa na topic ya software, si ndio? Samuel, so you on software? Samuel? Now for CBD, for EcoBank campus, we're on hardware. So as at now, we go almost the same. So I want to finish up topic hardware. So now we are looking at memory and storage. Memory and storage. Last week we were looking at CPU, the processor, input device, tukaangalia tena output devices. We have some people wana join, tena wanatoka. Wana join ni bundle. Ni nani? Leka mtoto. So I want to look at memory. Now, so we are looking at memory. So I say memory basically refers to a hardware device that allows you to store data, to store instruction and information for a short period of time, temporarily, for a short period of time. That's what we call memory. So we have memory and we also have storage. So we are saying memory allows us to store or keep data, instructions, and information for a short period of time. When you talk of a short period of time, we mean when the computer is being powered on, when the computer has power. Anything that is storing, it means whatever it is storing in terms of the content, and the content can be the data, can be the information or instruction. It is on what we call primary memory. Memory can also be called primary memory or main memory or internal memory. Main memory, internal memory, primary memory, temporal memory in kitu moja is a hardware device of a computer that enables a computer to store data, instructions, and information for a short period of time. When you talk of a short period of time, it means temporarily. What I can do, I want to use a board. So that I can explain. So basically, we have what we call allocation. Memory consists of billions of cells, and those cells are known as locations. So memory has, the structure of memory is like a ruled exercise book, which has several boxes. A small box is same as a cell. So a combination of cells form what we call a location. And the location has a unique name and a unique identifier. A unique identifier is not memory address. A unique name, you are the user to come up with that name. So I want to turn you, nikupeleke kwa board. Sio kama unaona my board. Naona? Naona? So what you are seeing here as the structure of memory. Structure of memory inakaa hivyo. And this memory basically has billions of cells. Hii moja is a cell. Cell ya CELL. CELL. So memory consists of billions of cells, and a cell can store data in form of 1 bit ama 1 digit. 1 bit ama 1 digit, which can either be a 0 ama 1. Remember, data inakuwa stored in zeros and ones. Data is stored in zeros and ones. So one cell stores data in form of 1 bit. Na tumesema 1 bit is same as 1 digit.
Hakuna wakati inatolewa hakuna explanation hadi kwanza ndio kabla.
1 bit is same as 1 digit. So we are saying basically a combination of cells form what we call a location. For example, these three, 1, 2, 3 cells form what we call a location. But tumesema a location has 3 components, 3 elements. One is name, yenye wewe ndio utakama up nayo. Tuseme hii location inaitwa X, inaitwa Y, inaitwa student name, inaitwa selling price, and a name. Allocation has what we call a unique identifier, a unique number. The same way we make admission number to uniquely identify you, because we can have 2 or more students wanna share the same name, but they are different students. So the same locations inapewa different unique identifiers, because in the memory we can have 2 locations zimepewa the same name, let's say X, but the content are different. Ziko different data ama different information in those locations. So a unique identifier of a location inaitwa what we call memory address. Memory address. Last time we said that the processor has a component known as the control unit. And tukasema the control unit basically is a component that does 4 major activities, 4 major functions. Fetching as one function, fetching. And tukasema basically fetching means retrieving data from locations. So if you have a location like hii nimechora hii inaitwa X, niko na number 2. Number 2 itaandikwa let's say 100. Now this data get related that from that location, lazima ijue the memory address of that location. So we are saying the control unit is a component of the processor that retrieves data instructions from different memory locations. For that control unit to do that function of retrieving data from a particular location, it must be given the unique identifier, the memory address of that given location. Then the last component of allocation is what we call size. Now size same as capacity. Whatever you are storing in these locations need variables, quantities. So these quantities need data. Now each and every quantity lazima ikuwe measured. The same way we have temperature as a quantity, distance quantity, volume, let's say voltage, current, lazima ikuwe measured. Now distance can be measured using different units. We can measure distance in kilometers, centimeters, meters,
centimeters.
Yeah. So the same data is a variable which must be measured, sorry. So we measure data using various units. So this size inamaanisha the volume of data that a particular location can take. For example, we can say the entire location and memory yote iko na let's say 2 GB ama 4 GB. So 4 GB is an example of size ya location ama your memory ama capacity ya your memory. So even if let's say my mobile phone has a problem with memory, niende ninunue memory ingine, that memory I'm buying lazima nikinunua nijue the size yake, capacity yake. And this size mainly means the volume of data that location, that memory can accommodate or take. So each and every location we create, if let's say the entire capacity ya hii memory yetu ya picking unit known as bytes, we can measure data in bytes. So kama let's say the entire capacity ya hii memory yetu ni 20 bytes, alafu I'm coming up with a location named X. Na hii X nitaka kuweka number 2. It means lazima ijue out of 20 bytes, X imechukua how many bytes. So each and every location we create, it has to be assigned a unique identifier, a unique name, and a size, ama capacity. And we say basically I tumia that size to store data in that given location. So the secondary storage na main memory, they're the same in terms of structure. Difference ni kuwa secondary can store permanently. Primary stores for a short period of time. That's the only difference. Temporarily, ingine store permanently. That's the difference between secondary na primary memory. So when I say primary memory is a kind of memory that stores data instructions for a short period of time. The structure of primary memory and secondary, they are the same. Secondary memory stores data and instructions for a long period of time. Meaning, let's say for 1 year, 1 month, 1 day, even if I switch my computer off, kitu kwa secondary haitapotea. Now, we have what we call types of primary memory. Types of primary memory. Primary memory has 2 types. One, ni random access memory. The number 2, inaitwa read-only memory. RAM na ROM. So basically, this diagram you are seeing, shows how the computer communicates na RAM, ama primary memory, na secondary memory. Now, the CPU is the brain of the computer. It has a small memory known as cache memory. Cache memory equal between the CPU na primary memory. Primary memory is the working storage of the computer. For example, if let's say on my mobile phone, haina WhatsApp, then I end up a Play Store na download WhatsApp. That's an instruction. Hiyo ni program na download. Lazima ikuwe installed. Once I'm installing that WhatsApp, it means I'm saving my WhatsApp for secondary storage. Now, when I have a need of using WhatsApp to communicate, kutumia mtu message, it means lazima nifungue WhatsApp. The moment I open WhatsApp, it means WhatsApp inaitwa na process. Inaitwa process because inahitaji 2 resources. Lazima iko kwa primary memory. Isipoweka kwa primary memory, the processor cannot execute WhatsApp. If the processor can't execute WhatsApp, inamaanisha me as a user siwezi tumia WhatsApp kuchat. So once I open here WhatsApp, inatolewa from the secondary, inaleta to the primary memory. Now, the primary memory in terms of speed, it can be very slow. So in a take long period of time, compare that instruction, the CPU. Another case can be CPU now equal very fast. When the CPU equal very fast, the speed at which it can operate is very fast. As compared to the primary memory, it means the computer's performance itakuwa chini. Because these 2 important resources, primary memory na CPU, they are very important. So in terms of speed, you cannot come across a computer whereby the 2, the CPU and the RAM, can communicate at the same speed. It means that computer is very expensive. One lazima ikuwe juu ya ingine in terms of speed. RAM ikuwe juu ya processor, ama processor ikuwe juu ya RAM. So in that case, it means we need something to balance, harmonize the difference in terms of speed of communication between CPU na primary memory. That thing is known as cache memory. That's why kuna cache memory kwa diagram hapo. So basically I say primary memory has 2 classes. Here we have features the primary memory. These features ziko in general. It is faster in terms of operating. Speed yake iko faster than secondary memory. Primary memory iko expensive than secondary memory. If let's say niko na 2 memories, moja ni secondary, ingine ni primary, na size yake ni same, zote ni 2 GB, ya primary itakuwa expensive than secondary. Higher, we are saying we have two types of primary memory. Two types of primary memory. So one is random access memory. The number two is read-only memory. Those are the two forms of primary memory. Now, tukianza na random access memory. So RAM inakaa hivi. These are photo of RAM, image ya RAM inakaa hivi. So RAM, one property yake ni volatile. Volatile inamaanisha ina store data when powered. The moment I lose power, data pia inapotea. It only stores data.
ROM.
Yes?
ROM ama RAM.
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 Tuko kwa RAM, random access memory. Iko volatile. Meaning, if you say that a memory is volatile, it means this memory can only store data when it is powered. The moment power inapotea, data pia inapotea. So RAM is volatile. Number two, I say RAM is expensive to acquire and maintain. Expensive. Another property, RAM ni nini? Read, stock, write memory. Read, stock, write memory. There are two operations we can perform on a memory. One, read from memory. Two, write into memory. Reading, it means tuna access kitu kwa memory. Retrieving data stored in a memory device, inaitwa reading from that memory. Adding data kwa memory, storing data kwa memory, inaitwa writing onto memory. So RAM, you as a user, you can access kitu kwa RAM. You as a user, you can also add content in terms of data na ingia kwa RAM. Another property ya RAM ni working storage. Working storage ya computer. Anything which the computer is working on as data, as instruction, lazima itolewe from RAM. That's when I an example. If I open WhatsApp, WhatsApp becomes instruction. Hiyo WhatsApp lazima ikuwe executed na processor. So lazima WhatsApp ipeleka kwa RAM. Ndio processor ende kwa RAM. Chenye nitapata kwa RAM, it means lazima ikuwe executed. Haya, we have what you call an image. RAM inakaa hivi. So there are different styles, different designs of RAM. This is a basic one. Haya, we have two types of RAM. Static RAM na dynamic RAM. Static RAM ama SRAM na dynamic RAM na DRAM. Static RAM is a stable RAM. It's a stable RAM. Inatumia the concept of what we call transistors to store data. So once you maintain constant power supply for your RAM, haiwezi poteza data. But dynamic RAM is not stable because inatumia what you call capacitors to store data. Your mobile phone has a battery. Your battery inatumia nini? Capacitors. Capacitors basically is a combination of cells. Na kazi hizo cells is to store charge. So hii ikistore charge, it means ina store data. Data inakuwa stored in form of charge. Now, once we are charging it, it means the same to a mobile phone. Your battery ukicharge, ita charge up to a maximum level na ijae na itaendelea kuacquire charge. Even if you connect kwa power supply, itakuwa imefikia hapo mwisho. Yako inakuwekeanga in form of percentage. Ikicharge ifika 100%, hizi endelea 110 pande hivyo, inaachia hapo. So the same for a DRAM, once it is being connected na power supply, ita acquire charge endelea up to a certain optimal level. Ikishafikia hapo, hizi endelea ku acquire charge. So once itafikia hapo, itaanza ku what you call ku discharge. Discharging means losing charge. So if lose charge hivyo, it means pia data inapotea. So dynamic RAM is not a stable RAM because inatumia capacitors to store data in form of charges. So a capacitor is a device that will acquire charge if you get a certain level, alafu yaanza ku discharge. So we are saying even if we are powering this dynamic RAM, still it will lose data through a process known as leakage current. Ile current na leak hiyo, data pia inaendelea ku leak. So if you want to prevent data loss on a DRAM, you continue topping up ama refreshing your memory to prevent data loss from a DRAM. Haya, then we go to tunaenda kwa ROM. Read only memory. Read only memory. Read only memory. Yes.
Rudia, ulikuwa umekwama mahali.
Wapi? Tumesema kwa dynamic RAM.
Yeah.
Nasema dynamic RAM is a form of RAM that uses capacitors to store data in form of charges. Hence, even if we power this device, even if dynamic RAM is powered, still it will lose data through a process known as leakage current. So if you want to prevent data loss from a dynamic RAM, you continue topping up current ama supply of voltage to that particular dynamic RAM, or you refresh your dynamic RAM. Haya, tunaenda kwa ROM. ROM. So ROM ni read-only memory. So ROM is non-volatile. Kitu ya kwanza. ROM ni non-volatile. Even if power goes off, kitu kwa ROM haizi potea. Number 2 is a read-only memory. RAM ni read stock write. Hii ni read-only. You only access. Huwezi add kitu kwa ROM. Number 3, ROM stores system information. Zinaitwa settings ama zita system configuration information. This is basically information which the computer requires from the initial stage ya booting mpaka vile utaizima. Hiyo data ikipotea, the computer cannot work. The same to a mobile phone. Tuko na device like a camera. Manufacturer wa camera ni mwingine. Camera iko na settings zake. Hata wewe ukienda delete hizo settings, it means camera hizi fanya kazi. So those settings za camera zinakuwa stored, coded on a device not a ROM na manufacturer. So you as a user, you cannot save your own data kwa ROM. Una access to. Now this is an image ya ROM. ROM inakaa hivi. Whatever you are seeing ya green, hii green ni motherboard. Haya. From there we have types of ROM. Types. So ROM iko na versions. 1, programmable read-only memory. Inaitwa PROM. These are a form of ROM that allows a user to program it. And programming memory in form of ROM inamaanisha chenye unafanya nini? Unaenda na delete chenye user, chenye manufacturer aliweka hapo, weke yako. Erasing the original data stored on that ROM by the manufacturer, then adding a new data inaitwa nini? Programming that memory. So PROM is a form of memory that allows a user to erase original data and save new data items, but you only erase once. You only program mara moja. Programming your device, you connect that device to another device and a PROM eraser. PROM eraser, it erase data kwa hapo, alafu allow you store your own data. Now, the second version inaitwa erasable programmable read-only memory. These are form of ROM that can be programmed several times. Hiyo ingine una program once, but hii una program several times. PROM you program it once, EPROM una program several times. That's the difference. The last one is EEE. Unaweza EEPROM. Unaweza sema EEPROM meaning erasable, electrically alterable PROM. Unaweza sema electrically alterable PROM. Ama useme electrically erasable PROM. Now, these also can be programmed several times. Difference ya hii na EPROM ni kuwa how you are going to program it. EPROM kuprogram, you connect that device to a PROM eraser. Is another device. EEPROM kuiprogram, unai-supply, you connect that device to a voltage of high current. It erase original data alafu save yako. Haya, another form of memory metaja inaitwa cache memory. Cache memory. Cache memory is a physical memory you can see and touch. Is a physical memory. Na ziko two forms. Moja iko part ya processor, component ya processor. Yaani iko kwa board ya processor. Tuseme processor is basically a chip. Na hiyo chip inawekwa nini? Cache memory on it. Is a physical memory of very high speed, meaning it can operate at a very high speed. The importance of cache memory ni kusema nini? Kuharmonize, kusynchronize how the CPU can communicate na primary memory ama RAM. Saizi venye mimi nawafunza hivi, if I'm too fast na wewe uko too slow, it means kuna some things zitakupita, ndio? Or let's say mimi Kuna mtu asema mimi I'm very slow hata kuongea, but you are fast. It means utaboeka on your side. So we have to harmonize how we can communicate so that usiboeke no vitu zingine zisipite. So the same, maybe let's say mimi ni CPU, wewe ni RAM. If I'm very fast, it means kuna some things zitapotea. If you are writing short notes, utapotea. So the same, if the CPU go very fast, it means RAM will be taking a longer period of time to prepare data and instruction. CPU inangojea, but RAM ina take long to prepare. Once they prepare, the CPU, because it go very fast, ina manipulate haraka. Alafu inataka ipay information, return information kwa RAM. Na RAM nayo ina take long kuchukua that information. This will affect the performance ya computer kuwa very, very slow. So we are saying basically cache memory na come between, harmonize, kusynchronize, ni kubalance, kusikuwa na some challenges, how the processor can communicate with the main memory. So kama processor iko very fast, cache ita communicate na processor at that speed. Kama main memory RAM iko very slow, cache ita communicate na hiyo RAM at that speed. That's the importance ya cache. We are saying cache memory is a high speed buffer memory. Buffer, it means in a stock it for some time. It accumulate the pair somewhere. So it's a high speed buffer memory that balances the difference in the communication speed between a processor and the RAM. Meaning it can communicate with the CPU at the speed of CPU. On the other side, it communicate with RAM at that speed of RAM. So tuko na two forms za cache. Cache inakuja with the CPU inaitwa internal cache ama level 1 cache. Cache yenye kwa external iko different. Kama hiyo tumeona kwa hii diagram, haiko part of the CPU. If you look at this diagram, inakuonyesha this cache is a form of external cache, iko kando iko vyake. But ningeweka hii cache ndani ya hii CPU, which means is an internal cache ama level 1 cache. Haya, another kind of a memory inaitwa virtual memory. Virtual memory. So virtual memory is not a physical memory. Si physical memory tunaiona unaitouch. It's basically an idea. Is an idea of utilizing a memory in a small capacity. If I have a computer and my memory, my RAM, size yake ni ndogo. For example, a mobile phone. I have a mobile phone, na RAM yake is 1 GB. And I want to open, let's say, multiple programs. Nifungue Facebook na WhatsApp zote. If I open Facebook alone, inajaza hiyo RAM. It means nikienda nifungue WhatsApp, haitakuwa loaded because RAM imejaa. So the importance of virtual memory will come in that situation to allow you multitask, allow you multi-program, work with multiple applications at the same time with your small amount ya memory. So itafanya aje? Kitu itafanya, if you open 2 programs at the same time like WhatsApp na Facebook, neone kuwa ikiload even WhatsApp alone inaenda inajaza memory yako. What it will do, it will divide those programs into small portions, small parts, pages, frames. Alafu ianze kuload kamoja to save on your memory, to utilize your memory. So you are saying virtual memory is just a concept of enabling one to utilize a computer with a small amount of RAM. How? By subdividing the programs that are being loaded kutoka kwa external storage ilete kwa primary memory into small portions, frames, segments. Alafu ina load ka segment kamoja nje kusave memory ya RAM yako. That's basically what we call virtual memory. Another one, you have what you call direct memory access, DMA, direct memory access. DMA pia is not a physical memory, just an idea pia in apply. This applies whereby whenever we